I want to welcome everybody to one of our leadership meetings for this year. A little bit more intimate. We're doing something a little bit different for this one. As you know, we didn't tell you what we were doing differently, but we did tell you we were going to do something different. We have brought in some guests that are going to challenge the way we think about a particular segment within the DE&I and belonging space. So we're going to have a lot of fun with that. I think you're going to really, really enjoy that. I'm going to take a big breath and sit back and release the mic. I'm going to give it to Mika, who is going to do the introduction of our lovely guest speaker. So we're excited about it. So take it away, and I'm going to go ahead and mute.
Okay, thank you, Chris. My name is Micha. In a few moments, you'll get a taste of what my company, Lecture, does for over 100 global companies. I started Lecture a few years ago because I wanted to inspire people in the workplace to get new insights and perspectives in a fun and interactive way. So this company actually took off like a rocket, and these days, talented young people, they want to get a lot more from their employer and their workplace than just a good salary. They are expecting things for their personal and professional development. And that's why I think that we hit the right spot. We do about 600 to 700 auditions per year, looking for inspiring experts who can share their knowledge and their insights with our audiences, from master forgers to plastic surgery, from psychiatry to slavery, from feedback to storytelling, and from intellectual property to machine learning. Everything people want to learn about for their professional and their personal development. We do actually everything for our clients. We produce, present, and moderate the sessions, and do this in a white label way. So we are the Heineken Inspiration Sessions, we are the Salesforce Lectures, we are the L'Oreal Inspiration Program, and we are the ING Global Insight Sessions. And we do so for over 100 companies around the world, with speakers from Vancouver to New Zealand. I hope you enjoy this great session with Antonia, one of my personal favorites, and hopefully many more to come.
Thank you. Thank you so much, Mika, for such a lovely introduction. And yeah, like all of the lectures I've seen have been absolutely amazing, such a diversity of topics. So you'll learn a little bit about me and my background and my area of specialty. Hopefully you can all see the slides okay. I want to start by saying that sometimes at certain points in your life, just a few words, maybe 3 words, end up changing the course of your life forever. And those 3 words might be, I love you, or they might be, I am leaving. But for me, the 3 words that changed my life were, I am bisexual and I am polyamorous. Now, I assume that most people know what being bisexual means, but to clarify, the bi in bisexual doesn't mean I'm just attracted to men and women. It means I'm attracted to people who are the same gender as me. So I'm female and my pronouns are she, her. I'm also attracted to people of different genders to myself. So men, non-binary people, genderqueer people. I'm attracted to people of all genders. But polyamory, or being polyamorous, is much less well known. So I'm really curious if anyone here has heard of polyamory and knows what it is. So feel free to type in the chat or unmute if you're feeling brave to interact, and let me know if anyone has heard of polyamory and has some idea of what that is. Okay, heard but can't define. Okay, so some people have heard of it. So sometimes we run this with a poll, and I tend to get a majority of people having never heard of it, and some people having heard of it but being unsure about it. So for clarity, being polyamorous is the opposite of being monogamous. So monogamy is the idea that you're in love with just one person at a time. You're in a relationship with one person at a time. Being polyamorous, poly means multiple and amory means love, means I believe it's possible to be in love, in a healthy loving relationship with more than one person at the same time. So that's the way in which I live my life, and that's part of who I am, my identity and my orientation. So saying those 3 words out loud, I am bisexual and I am polyamorous, might not seem like much of a big deal. And in many ways it's not. I'm not saying anything controversial. It's just a fact about my identity. And I'm very comfortable with who I am and open about my identity to my friends and to some of my colleagues. But I'd always kept it a secret from my family for my entire life because I didn't know how they'd respond. That all changed dramatically 4 years ago when my life turned upside down in a single night. To understand what happened, you need a bit of context about my background. So I'm a scientist. My background is in biology, specifically in animal behavior. I used to work in world-leading research laboratories, studying the behavior of different animals and publishing my research. Eventually, I ended up moving out of scientific research into science communication, and I became a full-time public speaker. I had the great honor of working at a number of different institutions, science museums, and zoos. And then one talk changed everything. In 2017, I was invited to deliver a Tedx Bristol talk. For anyone who's familiar with TED Talks, they're educational, inspirational talks. They've always been a big part of my life in terms of watching them. So it was a huge honor. And Tedx Bristol is enormous. It's one of the biggest ones in Europe, with a live audience of 2,000 people and many more streaming online. So it was a great honor to be invited to speak. And the talk that I decided to deliver, which evolved into the talk that I'm doing now, was all about LGBTQ behavior in the animal kingdom. I wanted to share with the world how beautiful and how diverse the organisms on Earth can be, especially the many ways that their bodies and their societies function, how they court, reproduce, and raise young, and how we as humans can learn from that diversity and shouldn't expect people to fit into a narrow mold. I felt that it was important to be clear about my own identity as part of that talk, but I was very nervous about it because I still hadn't come out to my family yet, and I really had no idea what their reaction would be. So 2 months before standing on that stage, I came out to my family, and it did not go very well at all. In fact, certain family members had a very violently negative reaction. I was threatened physically, I was blackmailed, and I was bribed. I was offered ongoing financial support only as long as I cancelled the talk and remained in the closet and wasn't public about my queer identity to anyone. I was called defective, abnormal, mentally ill, deficient, broken, depraved, and disgusting. Also, homophobic words were used that I won't repeat here. It was made very clear that this part of myself was something that I shouldn't be proud of, that in fact I should be ashamed of and keep hidden. I was obviously devastated. So I spent a long time agonizing over how I should respond and whether I should still go ahead with the talk. Because despite everything that they'd said to me, I still love my family, and I didn't want to do anything to hurt them. In the weeks that followed that incident, I kept replaying those words in my head over and over again. And out of all the threats and all the slurs that were spoken, 3 words in particular stood out to me. It's not natural. The idea that polyamorous behavior or queer behavior, whether that's being gay, bi, trans, asexual, or otherwise, is unnatural and therefore bad, is often used to try and justify bigotry against people in that community. And I'm sadly not the only person to have experienced this. A survey from 2017, published in Pink News, a queer news site, found that 4 in 10 British people here in the UK, where I live, believe that homosexual sex is unnatural. So it's a very widely held belief. But is there actually any truth to it? Well, I wasn't actually sure of the answer, but I knew I had to find out. I could not stand by while people weaponized my area of science to invalidate me and other people like me. As a queer woman and a biologist, I felt that I was uniquely situated to dig into the research and to find an answer. And maybe that would help me make a decision about whether I should go ahead with the talk. So I committed myself to answering these questions. What do we actually mean by unnatural? Is that meaningful? And do we see queerness in nature? So by literal definition, natural means things that occur in the world of plants, animals, and other non-human organisms. And presumably that's the same definition that people are using when they try and use that word to justify prejudice and bigotry. In fact, the exact words that my own mother used were, "You don't see the animals doing this." But by that definition, as humans, we do lots of things that are not natural. We wear clothes, we drive cars, we talk on phones. And in fact, if you want to talk about social behaviors, technically straight marriage is unnatural because you don't see animals getting married unless you have pets and way too much time on your hands. But you never see anyone protesting at straight weddings on the basis that they're not natural, because clearly that would be ridiculous. The idea that everything natural is good and everything unnatural is bad has a name. It's actually called the Gaia Fallacy, and it's very easy to disprove. For example, cyanide is a substance that is entirely natural, but it's also a fatal poison if you ingest it. So completely natural, but definitely not good for you. And as we've just illustrated, there are plenty of unnatural things that are not harmful. So the argument that being queer is not natural, therefore must be bad, falls apart completely. But as a biologist, it made me curious. Do we actually see LGBT behavior in the animal kingdom and in other organisms? Well, that's what I want to explore in this talk. First, we'll look at whether we see homosexual and bisexual behavior in the animal kingdom. And then I'll examine polyamory and animals which have non-traditional family structures. We'll see animals with unusual systems of choosing a mate or multiple mates to parent their offspring, and the benefits of those different systems. Then we'll touch on sex determination. That means what causes an animal to be male, female, both or neither. And finally, we'll have a quick tour of some of the most unusual mating behaviors in the animal kingdom. So I'd like to know what you think. How many different species of animals do you think homosexual or bisexual behavior has been documented in? Have a guess in the chat. Is it 0, 10, 100, 1,000, 10,000? Anywhere in that range? I don't want to narrow it down too much. All of them. It's not all of them, sadly. That's a great guess, though. But no, I think it would be very difficult to say that homosexual behavior is documented in all species, because some species, there's very little documentation around, particularly more rare or endangered species that are harder to study. Some people are putting percentages. I don't know as a percentage, so I won't be able to answer that. Price is Right rules. Oh, I like this. Okay, Barb, we'll do Price is Right rules. It's more than 1,000. So Chris also guessed 1,000. So yeah, it's higher than 1,000. We'll do Price is Right. You're quite close though. It's not too far off. It's not 50% though, sadly. Again, that's a lot of species. There's not much documentation on many species. I don't want to keep you guys hanging on too long. The suspense is too much. So the answer is, those of you who guessed 1,000 are very close. Homosexuality has been documented. It's more than 1,001. We could be here all day. It's actually just over 1,500, which is a huge number, really. And importantly, in a third of those, it's been documented repeatedly. It's a regular occurrence. So we know it isn't something that was a fluke or accidental. And those species are a really wide range. It's everything from African elephants to Asian elephants to giraffes, penguins, dolphins, lions, sheep, dragonflies, and also, importantly, every species of great ape, which is our closest ancestor in terms of evolution. So that's orangutans, gorillas, chimpanzees, and bonobos. In fact, in bonobos, who are very similar to chimpanzees, it's a bonobo in the top left of this slide here, 60% of their mating behavior happens between two females. So that's the norm for that species. And homosexual animals can also raise young. In New York's Central Park Zoo, there are two male penguins called Roy and Silo, and they formed a romantic pair bond. And a zookeeper saw them trying to hatch a stone. He also had a spare egg left over from a heterosexual pair who weren't nesting it. So he gave that egg to Roy and Silo. And they took turns sitting on it, and eventually it hatched into a healthy female chick called Tango. Their story was written up into an amazing children's book called Tango Makes Three, which teaches children that love is what makes a family. So clearly we do see homosexual and bisexual behavior in a wide range of animals, but what about polyamory? Well, this is a bit more difficult to answer because, as I mentioned at the beginning, polyamory literally means multiple loves. And that's not the same thing as having multiple sexual partners, although there's nothing wrong with that. And that is also a valid relationship option for humans as well. But it's a term that we can only really use for humans because we can't look for that in animals. After all, how would we quantify or know if an animal even feels love? So instead, we look for two different things. does that animal only mate with one other individual and only change if its partner dies or becomes inaccessible? If so, that's called reproductive monogamy, only mating with one other. Or does the species have a social structure in which the individual lives with and raises young with only one other? If so, that's what we call social monogamy. And social monogamy is very common in birds. Over 90% of bird species are socially monogamous, which means they only nest with one other individual, and often for life. That includes swans, black vultures, barn owls, and most penguin species. As we've just seen, those can be same-sex pairs, like Roy and Silo. Just 3% of mammals, though, are socially monogamous, which includes wolves, beavers, and gibbons. Mammals typically don't nest together for life or live with just one other partner. Reproductive monogamy is much harder to study because most of our understanding of animal social behavior comes from observing them in the wild. It's very easy to see if an individual's only nesting or living with one other partner, but it's quite difficult to document if they're mating with any other individual, because often this can happen in a sneaky way. Luckily, thanks to genetic testing becoming more affordable and easier to access, we're now able to trace paternity to understand who the father is of a certain individual. And it turns out that most species, even those that are socially monogamous, do engage in mating outside of the pair. That's called extra-pair copulation. And this is very, very common. It's more common to have multiple sexual partners, even in those species that were thought to be monogamous, like swans or gibbons. And some animals have brilliant strategies in order to achieve this. My personal favorite is this one, the cuttlefish. So larger male cuttlefish actually compete with each other. They fight to impress females. And once a male attracts a mate, he guards her and tries to prevent any other male from mating with her. But cuttlefish also have the ability to change the color and the texture of their skin. So smaller males adopt a disguise. In this picture, you can see a female cuttlefish on the left. That's the one with spots. There's a small male cuttlefish on the right, and there's actually a larger male, which is off screen on the far right-hand side. So the sneaky male is displaying female colors on one side of his body that faces his rival, the right-hand side. He's pretending to be a female, and sometimes they even hold an egg sac to complete the illusion. This allows him to sneak past the larger male and woo the female by showing these typical male stripes on that side of his body. So you can see that on his left-hand side. It's an absolutely brilliant strategy. Not all animals have to be sneaky about the way they mate. Many animals openly reproduce with multiple partners, whether they raise young with them or not. Mating systems are very diverse. You can have a promiscuous mating system, which means many males and many females. We see this in chimps and bonobos, our closest ancestors. You can have a polygynous system. That means one male, which has access to many females. We see this in gorillas, in lions, and in red deer. And that system actually has advantages for the female. When males compete for mates, it means that females are more likely to choose a high quality male. And that might mean their strength, their size. They might have a large or well-decorated nest or habitat. They might have impressive plumage or horns or fur. And that means her offspring are more likely to have that advantage themselves and to survive and mate, passing on her genes. A more rare system, but not unheard of, is polyandry. This is where you have one female and multiple males. And this has different advantages for the females, specifically something called sperm competition. When a female mates with many males, the one with the most and the fastest sperm is most likely to fertilize her. That's usually the male that is in the best health and has the best access to resources. Multiple mating in females also allows something called cryptic female choice. This is where a female can store the sperm of multiple males and sometimes even choose which sperm fertilizes her eggs. The spider on the right, Pisaurus mirabilis, is an example of this. Male spiders give food to the females, and the amount of sperm a female stores depends on the size of the gift of food. So better gift, more food, she stores more of his sperm, he's more likely to fertilize her eggs and pass on his genes. So it's not a bad deal. Having offspring with many mates also means there's more diversity among the young. So it's less likely they will all be wiped out by a single predator or a single parasite. This is a strategy employed by sea turtles who lay one clutch of eggs with multiple paternity, that is, one mother and multiple fathers. As you can see in this picture, sea turtle mating is a bit of a free-for-all. But spiders and turtles don't make very good parents. In fact, they're famously poor at parenting. So can these polyandrous or polygynous groups actually raise young together? In some species, this is actually a big advantage. Cotton-top tamarins, these small monkeys here, are very interesting to biologists because they actually have all different kinds of family structures. You can get one male with one female. You can get one male with two females. But by far the most common is one female to two males. And this makes perfect sense because due to a quirk of their genetics, tamarins tend to have twins. And males are the ones who care for the young. They only hand them over to the female for breastfeeding and then immediately take them back. Carrying those young is hard work. So males deliberately put on weight while the female is pregnant so they'll be strong enough to carry the young. And each male can take care of one twin. So having one female with two male partners makes things much easier for everybody. You may think this only happens because the males are potentially a parent and they're not sure if that's their young. And that is a possibility. But alloparenting, which means caring for young that you know are not your own, is actually very common in mammals. It's most common in animals that live in social groups. So it's been documented in 120 mammal and 150 avian species, so bird species. In mammals, alloparenting can mean allolactation, which means a female lactating and breastfeeding a youngster that is not hers. It could mean babysitting, protecting the young, sharing your food with them, or carrying them. Male Barbary macaques, a different species of monkey, are known to carry around babies that aren't related to them at all for hours at a time. So the idea of the nuclear family in the animal kingdom of mum, dad, and the young is actually a minority of species, despite the way that we portray it in films like 101 Dalmatians or The Lion King. It's actually not at all an accurate reflection of what we see in reality. Because in real life, we see family structures, parenting, pair bonds, and mating of many different kinds and combinations. So we've seen that homosexual and bisexual behavior, polygyny and polyandry all do occur in nature. So what about trans or non-binary? What else is natural? Well, to understand this, we have to understand the difference between sex and gender. And to help illustrate this, I like to use this diagram, which is called the genderbread person, which is both informative and delicious. Now, this is actually an outdated diagram, and it's slightly problematic. For example, it shows sexual orientation on a spectrum from hetero to homosexual, but this doesn't allow for asexual people who have no sexual orientation, and they clearly do exist. So this diagram is by no means perfect, and it's slightly out of date, but I do think it's useful to illustrate certain basic points. For example, this shows the difference between your gender identity, that's who you are, your orientation, that's who you love or are attracted to, your sex, which is your physical body, and your gender expression, that's how you perform or express gender outwardly. And all of these are a spectrum. It's never a binary. So it's very easy for us to understand how gender expression can be a spectrum, because we can present as more masculine or more feminine anywhere along a scale, maybe at one extreme or the other, but maybe with a combination of both or somewhere in the middle. Now, orientation is also a spectrum. I'm bisexual, but that doesn't mean that I like men and women equally or in the same way for the same reasons. And it can change over time as well. So it's a bit more complicated than it being equal, and it's certainly not a binary. Gender is also a spectrum. So many people, myself included, identify as 100% male or 100% female. But there are also many people who identify with aspects of both genders, or neither, or maybe queer or gender fluid. But the key thing I want to emphasize as a biologist is that gender is a psychosocial construct that only really exists in humans. It isn't said to exist in animals. We'd have no way of knowing if it did. So from here on in, I'm only going to be speaking about biological sex, that is the physical body of the animal, which does exist in the animal kingdom. So in humans, our sex is largely determined by our chromosome. And this is an X and a Y chromosome. You may recognize them from school. Don't worry if not. The simplified explanation is that biological males have this combination, an X on the left and a Y on the right, while females have two X chromosomes. But this is an oversimplification. In reality, your sex is determined by a number of factors when you're developing as an embryo. Your chromosomes are one of those factors, and that affects your gonads, whether you have ovaries or testes. That affects your hormones, your levels of progesterone, estrogen, and testosterone. And that affects your phenotype or your physical appearance, whether you have breasts or a beard. And at every level, there is variation. It's not a clear binary. Even at the chromosome level, there are people who don't just have X and Y, but they might have an X alone and no Y, or three X's, or XXY, or XYY. This is called numeric sex chromosome variation. And it's more common than you might think because some of these combinations don't present with any ill health or symptoms. So you may have a numeric sex chromosome variation and not even be aware of it. Actually, once giving this talk, I met someone who had a numeric sex chromosome variation, who was in perfectly good health and only found out because of something unrelated that they needed to get tests for. Similarly, at the gonadal, hormonal, and phenotypic or appearance level, we expect to see variation. For example, a person with typical chromosomes, XX or XY, might still develop intersex genitals. So that means they might have ovaries and testes, or neither, or kind of a middle ground in terms of the development. And genitals themselves are not binary. This is the Quigley scale on the top and the Prada scale below. These are used by medical professionals to describe the level of feminization or masculinization of human genitals along a scale or a spectrum. And even this is a simplification because it only accounts for the external organs. A person might have a womb and testicles inside their body, where it's not externally obvious at all. So even at the most fundamental level of human biology, even at our genetic level, there's a huge amount of variation. But it is true to say, broadly speaking, that X and Y chromosomes determine sex in humans. So can we assume this is true of all other animals? Well, let's think about the birds and the bees, starting with the birds, if you'll pardon the bad joke. So birds are a lot like humans. They do have sex chromosomes, but they're called ZZ and ZW. And in birds, males have two the same and females have two different, which is the opposite of humans. So we can already see that the human model isn't the norm across the animal kingdom. And in bees, it's completely different. A colony of bees has three types. There's the queen, who is a female. There's all the workers, who are also all female. And then there are the drones, who are male. So when you see a colony of bees working away, those are all female. The male bees don't do any work. And I apologize if that comes across as an inappropriate comment, but it is quite literally true in bees that all of the workers are females. The males are only born in order to have sex, and then they die. It's a short life. And the interesting thing about this is that the queen can control very precisely whether the egg she lays is male or female. Because if she fertilizes the egg, then it becomes female. And if she doesn't fertilize it, it becomes male. That means that sex in bees is not determined by chromosomes, but by how many copies of those chromosomes you have. And it also means that male bees have no father, which is quite weird to think about. You can see how studying the animal world makes us re-examine and question our own assumptions. And one of the assumptions we tend to make is that male animals have a penis and female animals don't. And as we've seen, that's not true in humans, but it's also not true in a wide range of other animals. This is a female spotted hyena. In this species, the female has something called a pseudopenis. It's an enlarged clitoris, and it looks identical to the male genitalia. She also gives birth through it, which is quite an achievement. I actually wanted to be very sure that this was a picture of a female, so I hunted down the photographer of this picture, Betty Watcher, and she confirmed that she did know this was a female because she had the scar tissue on her pseudopenis to indicate that she had given birth before. And that's in fact one of the only ways that professionals working with this species can tell apart males and females. Only if the female is a mother is it easy to tell them apart. Otherwise, it's incredibly difficult, even for a trained professional. Also, what I find interesting is that both males and females in this species can have erections, and it's a sign of submission or surrender, which again, maybe challenges our assumptions about certain things. So for all of the non-human animals that I've shown so far, they have a static sex, which means they're either male or female, and that doesn't change over time. But in many animals, sex is more fluid and it does change over time. The word for this is a sequential hermaphrodite, and clownfish are my favorite example. In a whole school of clownfish, there's usually only one female. She's the physically biggest and the top ranking fish, so she is very important. If she dies, the next biggest fish, which is a male, will turn into a female to replace her, which would have made the movie Finding Nemo completely different. And there are also animals which are both sexes at the same time. This is true of almost all slugs and snails. Banana slugs are my personal favorite example. Their Latin name is Dolichophallus, which means enormous penis, and it actually comes out of their forehead. When they mate, they form this beautiful yellow circle or yin-yang, and each one inserts its penis into the female organ of the other one. But as per their Latin name, it is very large, and quite often it gets stuck. And if it does, they have to work together to engage in a behavior called apophallation, which means chewing it off. So nature finds a way. And unbelievably, sea slugs actually take it a step further. This is two sea slugs. The big, wide brown part is their body, and that white part is called a stylet. It's their genitals. It has two ends, and it's very sharp like a spear. And they don't have a receptive organ. They actually just stab that reproductive organ wildly into the side of another individual in an act called traumatic insemination. And that's a good name because it is quite traumatic. It's kind of traumatic to hear about, but it is literally traumatic to the other individual. It causes them physical harm, but it benefits the giver because it means that the other individual is going to have to carry the young and take on the cost of that. So this has evolved in some species of flatworms into a competitive behavior known as penis fencing, where each individual will try and stab the other one while avoiding receiving any injury themselves. And while we're on the subject of sea slugs and their behaviors, I have to introduce this one, which is Chromodorous Reticulata. This is also a hermaphrodite, like the banana slug. Has both male and female organs, but it's very unusual in that it has a disposable penis. When it mates, its member just falls off, but that's okay because it has two spares stacked directly behind, like a mechanical pencil. When it mates, it just uses the first part, which falls off, and then the rest of it moves forward, ready to mate again. So it can only mate about 3 times. You may wonder why it would possibly do this. Well, the penis has these backwards facing spikes, and the idea is that they're able to remove sperm that's inside the female to ensure that only this individual, I shouldn't say the female, the one receiving, if they don't have females, the one receiving the spear. And the reason is they want to remove sperm. They want to ensure paternity of that individual. So biologists speculate that these spikes became longer and longer over time and harder to remove. And instead of making them smaller, it just evolved to lose its member completely. And it's not the only animal that has this strategy. The spider Nephelengis malabarensis is also able to detach its penis inside the female while it's mating. And that continues to inject sperm while he's free to fight off other males and to guard her. And that maximizes his chances of fertilizing her and passing on his genes. He also has an advantage in doing this because studies have shown that males who've detached their organ are lighter and able to fight for longer than males who haven't. So evolution is nothing if not incredibly inventive. Now, with all of these quite extreme mating strategies, you may wonder, have any animals just opted out and reproduce without sex? And in fact, that's true. Asexual reproduction, being able to pass on your genes without any kind of sexual interaction, is found in nearly half of animal phyla. So huge swathes of creatures are able to produce viable offspring without any sex at all. Some species are only able to reproduce asexually, and for others, it depends on their circumstances. Most of these are microbial or single-celled organisms that don't have any kind of sexual interaction. They just split and bud. But it's not only microbial animals. Some larger organisms can lay eggs without having to reproduce. And that process is called parthenogenesis. This has been documented in hammerhead sharks, in blacktip sharks, boa constrictors, marbled crayfish, and Komodo dragons. But asexual reproduction is also, unfortunately, not always peaceful. This is Macrostomum hystrix. It's a flatworm that, like the sharks and the Komodo dragon, can reproduce asexually if it needs to. So you may remember from earlier that flatworms engage in traumatic insemination. This individual would prefer to find a mate, but if it doesn't, it has no choice but to self-fertilize, which it does by stabbing itself in the head. I think its expression really says everything you need to know. Life will always find a way. In some species where sexual reproduction isn't necessary, even the concept of having two sexes isn't necessary either. And so it's completely possible, although rare, to have a species which is only one sex. The desert grassland whiptail lizard is just such an animal. Every individual on Earth of this species is female. There are no males at any time. They reproduce by laying eggs, which have kind of a shuffled gene set of themselves. So they're not quite clones in a process which, as I mentioned, is parthenogenetic. But what I find interesting is they don't lay eggs all the time. They only start ovulating and laying when they're mounted or climbed on top of by another female. And believe it or not, there are even animals in which there are more than two sexes. Tetrahyena thermophylla is a single-celled animal that has 7 different mating types. And functionally, these are the same as sexes. It can mate with any other type except its own. Even more incredible is the fungus, Schizophilum commune, which has not 7 mating types, but 28,000. Even with all of these examples, this is really a tiny fraction of the weird and wonderful behavior that we see in nature. The spectrum of life on Earth is so diverse and eye-opening and amazing. That's what drew me to biology in the first place. And that was the reason I was inspired at first to write this talk. I just wanted to share with the world how incredible our planet really is. But when I came out to my family, that gave me a new reason. I was called abnormal, defective, and told that my behavior is not natural. Those words were meant to silence me. But instead, it just proved to me how important it is to speak up. I knew that other queer people might be hearing the same thing from their own family or from other people around them. And that maybe hearing this talk could help, maybe help them feel validated or give them something to say back when told that they were unnatural or abnormal. So in the end, I decided I would go ahead with the talk. And a number of things happened as a result. It had a really positive reception, both with the live audience and online. It's reached 150,000 views now and counting. I was invited to speak at a number of different institutions, festivals. Mika found me through it, and I was invited to speak with lecture. And I joined in with a lot of different groups in terms of LGBT activism. I was also nominated and shortlisted for the John Maddox Prize from the scientific journal Nature. And that's awarded to those who stand up for science in the face of adversity for the sake of social good. Most importantly, I think, I started getting messages from other queer people from all around the world, from Ghana, New Zealand, Spain, America, everywhere I can think of, saying that the talk did help them, either to come to terms with who they are, or to see that homophobic and bigoted arguments have no basis in science. So what I learned from my investigation is this: biology cannot be used to justify bigotry. In fact, I think the opposite is true. Because the more we look at and study the natural world, the more we are forced to question our own most fundamental assumptions about sex, attraction, orientation. So the next time you hear someone say that LGBT is not natural, please feel free to share with them why that just doesn't make sense. First of all, natural doesn't mean good. Unnatural doesn't mean bad. But even if it did, nature, the way that creatures survive and pair and reproduce in the natural world, is incredibly, unimaginably diverse. And I think that's beautiful. If you remember just 3 words from this talk, let it be this. This, all of this is natural. Thank you so much. I'm really delighted to be speaking with you today. We've got time for a Q&A now. So please feel free to type your questions in the chat. I'll pick them out and answer them. Nothing's off limits. So if you want to ask a biology question, that's completely fine. If you want to ask a personal question, also completely fine, whether it's about being bi, being polyamorous, about my kind of experience, my family, anything like that. So yeah, thank you so much. Oh, thank you.
I'll jump in real fast while folks are maybe putting their questions together or dropping anything in chat. Antonia, thank you so much. We're just so happy to have you on. As a very different sort of speech and presentation that I think our leaders are used to. And the idea here was to mix it up and challenge them. Also done a little bit differently. We normally lock these down and don't record the leader sessions, or when we do, we just make them available to the leaders. But I think this portion, this front half of the meeting, we are going to go ahead and make available to any of their team members. If they want to share this with their teams internally, or just share that within the site, we're gonna make that available. Good to see all of you. Thanks so much.